And we know that atomic number is, each element has different atomic number in the periodic table, and you see hydrogen has 1, helium has 2, uranium has 92. Now we are going to define law of definite composition. Alright. So what this law about? So it states that compounds always contain the same elements in a constant proportion by mass. For example, I'm going to give you an example. Water. Water is always 11.2% hydrogen and 88.8% oxygen by mass. So no matter what so that's definite composition. That means it always contains the same elements in a constant proportion by mass. Okay? Now we are going to talk about chemical formulas. Chemical formulas. Alright. First we need to define molecule. What is molecule? So that we need to define a unit of matter composed of two or more non-metal atoms. That's where is molecule formed, right? And a chemical formula is an expression of the number of atoms of each element in a compound. So, for example, the chemical formula of sulfuric acid. Sulfuric acid. We can write H2SO4. So that way we can write chemical formulas. And how do we interpret? For example, now let's see if we have C6H6N2O. This is a molecule of vitamin B3. Okay, in that one you have carbon 6 atoms, hydrogen 6 atoms, nitrogen 2 atoms, and oxygen 1 atom. Right? So sometimes it's saying other way around, the compound that contains 6 carbon atoms, 6 hydrogen atoms, 2 nitrogen atoms, and 1 oxygen atoms. What's the formula? So you can write C6H6N2O, and that's how you can write that formula. I'm going to give you another example of, let's say, C2H4OH2. When there is a parenthesis here, that means these two should multiply inside it. Any number outside of the parenthesis, it should go inside, multiply inside it. So for that, carbon is 2, hydrogen is 4 plus 2 because there is a 2, and then oxygen is 2. So that's how you can write how many numbers of atoms in a formula unit. Right? We'll work on the few more examples.